Hello, AquaHackers. I'm Marta Green.
My name is Heather Larratt. Thank you for joining us on this important issue of contaminants in stormwater. Stormwater is not a new problem. It suffers from the usual maladies: hydrocarbons, many quite toxic, metal contamination, and pathogen indicating E. coli, often at outrageously high concentrations. Like so many places in the world, stormwater is delivered untreated directly into Okanagan streams and lakes. Stormwater is diluted by stream flow and may meet all aquatic guidelines, but stormwater contaminants accumulate to exceed concentrations in lake sediments. Lake sediments then act as a storehouse. So how do you get summer-long weekend turbidity spikes at intakes, a phenomenon that can't be explained by any natural processes? Heavy boating, large boats, are suspected of causing these long weekend turbidity spikes. We used aerial and underwater drones to see and verify those impacts and the depths at which they occur. Even though we ran this trial as far away as possible from the South Kalmak intake, they still experienced a turbidity spike about 24 hours later.
Stormwater also reaches our groundwater and causes pollution in our water supply wells. 25% of BC's population relies on groundwater for drinking, and fish, believe it or not, rely on the cool and clear groundwater when it discharges to streams as base flow in late summer months. Unlike summer surface water intakes that are sometimes in protected watersheds away from human influence, aquifers tend to be in valley bottoms right under our feet. Any rain and snow that falls on our urban landscape and picks up contaminants can make its way into our aquifers via dry wells or slotted pipe manholes under catch basins. Aquifers do a good job of filtering out many insoluble contaminants like pathogens and the turbidity in stormwater, but soluble contaminants included salts, nitrates, and some hydrocarbons can move a long way. For groundwater, existing treatments are shown here. On the top right, you've got perforated manholes, or also called dry wells or soakaway pits, that don't offer much treatment besides maybe a bit of settling at the bottom. On the bottom right and top left are infiltration trenches, which are large areas underground filled with gravel or drain rock, and a series of perforated pipe to spread the water out. On the bottom left is a bioswale using a combination of surface features including plants that remove a bit of pollution and gravel soakaway pits. There are pre-treatment options such as oil water separators if you're really lucky. The problem with these is they're really expensive. The units, like one shown here, they start at $4,000 each. So for cities that have hundreds of these, or individual farms or commercial and industrial property owners, this price is out of reach. We need your help. Can you think of a more cost-effective solution?
Can we create an Okanagan toolkit to manage stormwater? Can we use rain beneficially, treat it locally, and as a last resort, treat it at outfalls? And can we do all of this safely? We need your help.
Welcome to beautiful British Columbia. Welcome to the Okanagan. Life in the Okanagan is defined by our water: swimmable, drinkable, fishable. Our water supports our economy. Through agriculture, tourism, forestry, water built this area. Our hot sandy beaches, a lifestyle for residents and a destination for visitors. And a beautiful place to live and grow. Invasive zebra and quagga mussels are spreading across North America, covering beaches, lake bottoms, and changing the ecosystem, damaging property and changing recreation, infecting our water systems. In just 6 months, invasive mussels can turn a functioning system into a management nightmare. The problem is complex, with watercraft traveling across North America, potentially carrying these invaders from one water body to another. Is this the future of the Okanagan? I challenge you to come up with a technological solution to prevent the spread of aquatic invasive mussels, to mitigate the damage they do to our infrastructure, or to control their population in infested areas. I'm James Litley from the Okanagan Basin Water Board, and I'll be here to help you with your solutions to protect what is important to me and to all of us.
I'm Robin Burke, Engineering Advisor for Flood Modeling with Natural Resources Canada.
I'm Steve Lipke with the Fraser Basin Council.
And I'm Heather McGrath, a geospatial scientist with Natural Resources Canada.
Flooding is Canada's most common recurring natural hazard. Each year in Canada, on average, there is over $1 billion in flood damages and costs. Some of this borne by insurance companies, a lot of it borne by different levels of government, and the rest of it borne by homeowners across Canada. We also know that up to 94% of homeowners in Canada don't have a sense for their individual or home level flood risk. And we think that this is a significant issue in terms of being able to mitigate flood risk, increase community resiliency, and decrease community and homeowner vulnerability to flooding. So one of the main issues that we have is trying to figure out how to communicate flood risk in an effective way. And there are a number of issues with the way that it's currently being communicated. And a good example of that is the 1 in a 100-year flood. We've seen in the Ottawa area that we had floods approaching or exceeding the 1 in a 100-year flood in 2017 and 2019. And this is quite confusing for people who live in flood zones or even outside of flood zones. So what we want to do with this challenge is figure out a way to better communicate flood risk to homeowners, to communities, to governments, anybody who may have to understand flood risk to make decisions for their employment or for their home and their families as well. So we're excited that you're all going to join us here on this challenge. We've presented a slideshow that we can sort of use to talk you through what we're trying to do. We think that if we can really tackle the communication piece, this can have a really significant impact on some of the easier pieces to tackle in terms of flood risk and reducing flood risk. So we know that there are some major challenges, including data acquisition, challenges in terms of climate change and uncertainty in modeling. But if we can figure out a way to better communicate flood risk, then I think we can probably engage people a lot better and maybe be making better decisions about how to reduce our flood risk in the future.
Hey hackers, it's Jen here from the Regional District of North Okanagan.
And Ed from the City of Kelowna.
And we spend our days trying to help our communities find ways to be more efficient with their water use. We use a lot of water on our yards in the Okanagan. 1/4 of the water used every year goes to lawns. How do we get people to change their habits?
You're right. Without crisis, change rarely happens. So we need people to be aware of how important water use is, accept that it's worth personal action, and putting it into place. Our valley has limited water supply, and how we use it impacts everything from stream flows to water supply to fish habitats, just to name a few. We've tried a number of positive reinforcements and negative consequences to try and bring that change, but we need to do more. Climate change demands that we do more.
Hackers, you might have the next big idea to help us with this challenge. Bring your solutions to the AquaHacking BC 2020 challenge.
My name is Tessa Trebasket. And my name is Sarah Alexis. And we are SEAL Youth Water Leaders. We've been working together in the natural resources sector for over 4 years in our nation.
One of our elders always reminds us that they used to drink the water directly from Okanagan Lake. Today, no one here would dream of drinking that water, as well as the creeks and rivers. There's been so much contamination. This is why we chose the issue that many Indigenous communities across Canada don't have access to safe drinking water and are on boil water advisories.
Chose this particular issue because we know as SEAL people, we have a responsibility to uphold the integrity of water itself. We also chose this issue as a means to shed light on the basic human rights, access to clean potable water. We really encourage a lot of collaboration, a lot of innovation, and the chance for students and participants to step outside their boundaries, step outside of their comfort zones, and find those areas of overlap where we can work together to address this issue.
Please join this AquaHacking challenge to help us find solutions to safe drinking water for our communities.